Now, I would like to introduce our speaker for today's webinar, a deep dive on Amazon Glacier with new retrieval features. Our presenter for today is Moz Kubo. Moz is the Senior Product Manager for Amazon Glacier. He has been with AWS since 2010 in various roles supporting storage, mobile, and edge services. And for the last 2 years, he has been leading product management efforts for Amazon Glacier. Our subject matter experts answering Q&A throughout the presentation include Henry Zhang, who is a Senior Product Manager with our storage team, and Rashad Animesh, one of our software development engineers for Amazon Glacier. And with that, we will now kick off today's presentation, and I will pass the mic on to Moz.
Hello, everyone, and thank you for joining the Amazon Glacier Deep Dive webinar session. As Nicole said, my name is Moz Kubo, and I'm a product manager for Amazon Glacier. And in today's webinar, I'm going to cover how Amazon Glacier can help you meet your archiving needs. A couple months ago, we celebrated the 4th anniversary of the launch of Amazon Glacier, and it's been really exciting to witness the tremendous growth, both in terms of the volume of archives that customers have securely stored on Amazon Glacier, as well as in terms of the growth in the breadth of use cases that Glacier is supporting for customers, ranging in various areas such as media and entertainment, healthcare, and life sciences, financial services, and many others. And I'd like to start today's talk by highlighting a few customers who are leveraging Amazon Glacier today to support some pretty amazing applications. Sony DADC New Media Solutions uses Glacier today to power its digital media supply chain solution called Venue. Previously, Sony was managing a tape solution with over 9,000 tapes. It was complex and required millions of dollars in capital investments every few years. They wanted to find a new solution that was simple, cost-effective, durable, and secure, scalable, and it would provide them with the performance and reliability that they required to power Venue, which delivers large amounts of data to their end users all around the world. They chose Glacier because it provides all of these aspects. Glacier removed the need to manage a complex and high-touch backend system. Sony estimated that Glacier is saving them over $10 million over the next 7 years. Sony stores a single copy of their data in one AWS region, and with Glacier's geographically redundant durability model, Sony is achieving a higher durability for their data, their valuable data, than multiple copies of tape, which they were maintaining previously. Sony loves that Glacier can support their tremendous ongoing data growth of a petabyte every quarter. And finally, with Glacier's new flexible, powerful, and low-cost retrieval options, they're able to access all the content they need when they need it to meet their business SLAs. Next, a large number of enterprise and government institutions are using Amazon Glacier to compliantly store sensitive data that's bound by various regulations. One example is Philips Healthcare, who runs their healthcare health suite digital platform on AWS. Amazon Glacier is one of 9 HIPAA-eligible services on AWS and enables customers like Philips Healthcare to transmit and store sensitive patient data that's known in the HIPAA world as Protected Health Information, or PHI. In addition to meeting regulatory requirements, Philips needed a scalable solution to accommodate the large amount of patient records and medical images that are produced across the 1,500 hospitals that it supports and produces this data daily. Furthermore, Philips has to retain this patient data for the lifetime of the patient, meaning many decades of data retention. And so not only did they need a reliable long-term solution to securely and durably store their data for decades, but one that could do so cost-effectively. Philips found that Glacier met all of those requirements. Stepping back for a moment and looking at storage overall on AWS, customers have taught us over the years to look at cloud storage based on 4 key elements. There's file, object, block, And then there's the batching and streaming capabilities that are underneath those products. And often multiple elements are required to build a successful cloud strategy, cloud storage strategy specifically. And the customers I've spoken with really consider AWS the gold standard for cloud storage and love leveraging the breadth and depth of AWS's storage products as well as the feature sets that are underneath those. And we're continuously gathering feedback from customers and iterating quickly to meet those customer needs. For example, customers for a long time asked for file systems that worked at a petabyte scale and with consistent latencies. And so we launched the new Elastic File System, which offers a simple file interface for EC2 instances, and it's highly scalable and performant. S3 and Glacier are our object storage offerings and are the ultimate repository that is both durable and cost-effective for everything from cloud-native applications to large big data workloads and others. And then there's Elastic Block Storage, which provides the lowest latency in the portfolio with provisioned IOPS and general-purpose SSD volumes for high IOPS and low latencies, as well as low-cost throughput-optimized storage volumes to lower the cost of using persistent block storage on EC2 instances. And EBS supports a broad range of workloads from transactional databases such as MySQL, SQL Server, Oracle, NoSQL databases like MongoDB and Cassandra, as well as big data like Hadoop and data warehousing. Furthermore, customers have asked for a variety of means to move and analyze data that come in and out of the AWS cloud that best suit the value and the time and workflow demands of their data transfers. And among those means offered today on AWS are Snowball and the new Snowball Edge and Snowmobile, which make large, even petabyte scale data transfers fast and cost effective. Storage Gateway, which provides a secure and seamless integration between your on-prem environment and AWS's storage infrastructure. Then there's Direct Connect, which provides a dedicated, secure, high-speed connection between AWS and your data center, as well as a plethora of third-party connectors, including consumer, all the way up to enterprise-grade storage management software, integrated NAS devices, and other third-party storage gateway appliances. There's also S3 transfer acceleration, which uses optimized network protocols and the AWS Edge infrastructure to offer accelerated data transfer speeds that can be as much as 5 times higher than the general public internet. And finally, there's Kinesis Firehose, which offers real-time analytics of streamed data and offers built-in BI tools and dashboards. So this really summarizes the storage product portfolio that AWS offers today. And as I mentioned, we are constantly collecting feedback and iterating to meet customer needs. When it comes to data archival, there's a trend that we've observed across all industries over the last few years, which is the explosion of data and the need for a scalable, durable storage solution. And this has been driven by a number of trends, including the proliferation of data-producing devices like mobile phones and IoT devices, the expanding use of sensors, such as in connected cars, to collect data for analysis, the increasing size of data of new formats of content, such as 4K and 8K videos, as well as the ever-increasing pixel count for cameras, the rapid advancements in genomics in the healthcare life sciences space, where a single genomic sequence can take up over 1 terabyte of storage, and this number continues to increase as the technology gets better. And lastly, there's kind of this virtual cycle in cloud storage, where as the prices of cloud storage have dropped dramatically over the years, customers have been able to store a greater amount of data for longer periods of time, which enables them to extract more value from that data. And this in turn increases the demand for cloud storage and thus increases the scale of AWS, which helps us increase efficiency and reduce our costs, which we then in turn pass on to customers in the form of price drops, which then leads back to more storage demand. And case in point, just a couple weeks ago, we dropped the prices of both S3 and Glacier storage prices yet again. Regardless of the use case or industry, companies face large and fast-growing storage requirements. And many face the challenge of finding a solution that's secure and durable, that's scalable, that's cost-effective, provides flexible data access, and that's also compliant. And so in this session, I'm going to discuss and go and dive deep into Amazon Glacier and how it's designed to help and address these concerns for archival workloads. And whether this is your first time learning about Amazon Glacier and you are either considering moving your archival workload to Amazon Glacier or are anticipating data archival needs in the future, or you're already using Amazon Glacier and are here to learn more about our new features and how to make better use of Amazon Glacier to optimize your archival workflow, you're going to get a lot out of today's session. And if there's one thing I want you to walk away with from this presentation, it's that Amazon Glacier is an extremely low-cost, powerful, and flexible data storage solution that can address the full spectrum of your archival use cases, ranging from deep archives that are never retrieved to active workloads with minute-level access, such as media broadcasting, all the way up to petabyte-scale content distribution or big data analytics use cases. So really, what is Glacier all about? Glacier is cost-effective. Data stored on Amazon Glacier starts at just 0.4 cents per gigabyte, less than half a penny per month. This comes after our announcement last week, as I mentioned, of dropping our storage price by 43% and continues our tradition here at AWS of innovating to reduce costs and then passing those savings on to our customers in the form of price drops. Amazon Glacier is offers powerful and flexible data access options. We also announced a couple weeks ago the launch of new retrieval features that make it easier than ever and more cost-effective to access your Glacier data. Glacier is durable. We offer 11 nines of durability. In mathematical terms, 11 nines of durability means that out of 10,000 archives, you might expect to lose one every 10 million years. And but what does that mean in terms of tape? If you're using tape, what would be a good comparison for that? And we asked a large Hollywood studio to run the same Markov model to determine the number of nines for 2 copies of tape, and which we used to calculate the 11 nines for Glacier, and they came back with 5 to 6 nines. And what that means is that having 6 more nines means that Glacier's durability is 6 orders of magnitude more durable than 2 copies of your data on tape. So this gives you an idea of the durability and safety of your data on Amazon Glacier. Amazon Glacier is highly secure. All data is encrypted at rest by default. Glacier is also very highly scalable from anywhere from gigabytes to exabytes and can accommodate any data growth that you have. And finally, we offer a suite of management features, including everything from compliance to audit logging and cost management, and I'll cover all of those throughout this presentation. From a value proposition standpoint, especially compared to traditional archival solutions to date, Amazon Glacier really removes that need for upfront capital expenditures that, in particular for archival hardware, which involves risky long-term investment horizons that require you to live with your solution of choice for many years. Amazon Glacier, with Amazon Glacier, there's no commitment, and you simply pay as you go for only the storage that you use. And we remove the need for time-consuming capacity planning for that traditional kind of on-prem solution hardware, as well as ongoing negotiations with multiple hardware and software vendors. We help you avoid the risk of physical media handling, and we enable you to control your geographic locality. Glacier is offered all across AWS's regions across the world and allow you to meet the performance and compliance needs that you require. So there's several key terms that I'll be using throughout this presentation, and 4 key concepts that encompass the areas that I'll be diving into as they relate to Glacier. So starting with the key terms, with your AWS account, you begin using Glacier by creating a vault. which is Glacier's term for the container in which you store your data. And you can create up to 1,000 vaults per account. In your vaults, you store archives, which are the basic unit of data for Glacier. There's no limit to the number of archives that you can store in any given vault, and archives can be as large as 40 terabyte. And also they are write once. The Glacier inventory is a cold index of your vaults and archives, and inventories are refreshed every 24 hours. As for the key concepts, in this presentation I'm going to be diving into multiple ways that there are to access Glacier and to upload archives into your vaults. And then you can also use several management features to meet compliance requirements, control costs, or monitor your Glacier account. And finally, there are several ways to both execute and manage data retrievals from Glacier. So jumping into the ways to access Glacier, there's really three ways. The first is to interact directly with Glacier using its APIs or SDK, which gives you full access to Glacier's features and APIs and provides a great way to build applications on Glacier. Now, like any AWS service, it's always good to be sure to be really thoughtful and diligent to set up access policies for your Amazon Glacier account that meet your security requirements around who can upload, access, or delete your Glacier data. The second way to access Glacier, which is also one of the most popular, is via S3 Lifecycle policies. If your application or your data set also uses S3 storage, then using Glacier by transitioning your S3 objects into the Glacier storage class is a simple and powerful way to manage all your object storage within AWS. And lastly, there's a large and ever-growing number of third-party vendors that integrate with Glacier, ranging from free consumer-grade tools like Fast Glacier and Cloudberry, all the way up to enterprise-grade applications and storage gateways like Commvault, NetApp AltaVault, and many others. And one thing to keep in mind when using third-party tools is whether your archives are kept in their native format or whether they are reformatted by the third-party tool for different reasons like compression or indexing features. Many customers find it useful to have their data in its native format when it's stored in AWS because it provides the flexibility to then use that data for analysis or other workflows without having to use the third-party tool in the cloud to understand the way the tool formatted your data. So just a little tip to keep in mind when and or if you are considering third-party tools to interact with Glacier and with AWS. So we offer several ways to transfer large amounts of data into Glacier quickly, as well as cost-effectively if you have a large amount of data. So in addition to the public internet, if you have large amounts of data that you need to transfer, such as terabytes or even petabytes, either as a one-time migration, such as decommissioning an old tape library to move to the cloud, or on an ongoing basis, there's other services that we offer to make that easier and more flexible. If it's on an ongoing basis, such as like mass content distribution use cases, Direct Connect provides a dedicated, secure, high-speed connection between AWS and your data center, up to 10 gigabits per second of bandwidth per connection, and can dramatically reduce the cost of egress. And it's something you should consider if this is your use case. If you need to transfer anywhere between terabytes or even exabytes of data, especially for one-time migrations, such as decommissioning, as I said, old tape libraries or data centers even, then we offer Snowball, Snowball Edge, and Snowmobile. Snowball Edge and Snowmobile, which we just announced at reInvent recently, to enable you to transfer large amounts of data quickly and cost-effectively. And in particular, if you're in an area with little to no network connectivity, then this can be really powerful. And our recently launched Snowball Edge product, which includes local compute capabilities, enables all sorts of other use cases, such as IoT, where you can perform analysis on raw data locally, and then quickly and easily add them to a big data analysis pool in the cloud, for example. If you choose to use Glacier's APIs directly, when you upload data, we pass back an archive ID and then throw away the file name. And many customers will then maintain their own local mapping of files to those archive IDs. When uploading data via Glacier's APIs, one feature that is sometimes overlooked is that you can add up to 1,024 character description for every archive. And this could include the file name, or it could include other indexing metadata. And this is a kind of useful tip to safely store that index, or have a copy of your local index in the cloud in case something were to ever happen within your with your local copy of the index. And another tip as it relates to uploading data, Glacier you should use Glacier for data sets where the average archive size is at least a few megabytes. The reason for this is that there's a 32 kilobyte overhead that's associated with every archive and is charged for that storage. And having an archive size of at least 3.2 megabytes means that this overhead charge will make up less than 1% of your total Glacier costs, which is, for most customers, is acceptable. And so if your average archive size is much less than that, you might consider aggregating your data into larger archives before uploading in order to minimize this overhead cost. And when it comes to aggregating your data, one thing that many customers who do this do in order to better maintain their data is to store the checksums for each file within that aggregated archive. This becomes particularly useful in the context of leveraging one of our retrieval features, which is range retrievals, which allows you to pull a specific byte range within a Glacier archive. So if you know a priori what the byte range is for a specific file that you're wanting to retrieve, and it's as well as its associated checksum, you can minimize storage costs by aggregating while still being able to retrieve only the data you need, thereby minimizing also the retrieval costs. The checksums in this case will then also help validate that the data that you retrieved is complete. One other tip on uploads is related to a feature that we offer, and one thing that customers find is that while HTTP is great because it's a widely adopted standard, it's also known to be not the best for handling very large archives. So customers leverage multi-part uploads to better ensure that large archives will make it, and as well as to improve the upload time of a single archive and enable you to better utilize your bandwidth by spreading out operations over smaller chunks rather than risk clogging your pipe by suddenly uploading a large archive all at once. Multi-part uploads is a simple three-step process where you first initiate a multi-part upload and specify the part size. We then pass back a multi-part upload ID, which you'll then pass back to us with every part that you send. Once all the parts are sent, you complete the multi-part upload by sending us an API call for completing it, at which point we will send back to you a single archive ID that represents the sum of those parts. So this is a great way, again, to both better utilize your bandwidth, help ensure that large archives are sent successfully and more quickly. As I mentioned previously, if you have an online storage layer in conjunction with your archive layer, and in AWS's case, if you're using AWS or Amazon S3, as well as requiring an archive data set, then accessing Glacier via Lifecycle policies is a great way to go. You can use Lifecycle policies to automatically transition data from S3 standard or S3 in frequent access down to Glacier based on the age of the data. You can also define policies to automatically delete data after a certain age as well. Lifecycle policies apply at the S3 bucket level, meaning that the policy applies to every object in that bucket that meets the policy's criteria. However, you can also specify a prefix so that the rule applies only to the objects in that bucket that have that prefix. In the example above, objects with the logs prefix are transitioned to Glacier 30 days after they are created and then deleted after 365 days. Once a policy is written, all the transitioning happens automatically based on the definition of that policy. So in other words, there's no more action necessary on your part for data to be transitioned to Glacier or eventually deleted. Do keep in mind that standard request fees apply even though you aren't explicitly making a call to transition that data. When an object is transitioned, the standard request fees for putting that object into Glacier do apply. It's also worth noting that one of the great benefits of transferring data to Glacier from S3 via lifecycle policies is that the S3 keys are maintained, and nothing changes in terms of your application. Nothing needs to change in terms of your application in terms of pointing to those specific objects. Now, many customers keep a lot of their data or all of their data in the same S3 bucket, typically for application design reasons. And oftentimes they only want certain sets of objects in that bucket to be transitioned to Glacier. However, since lifecycle policies apply at the bucket level, some have found it challenging to write policies that only apply to the objects that they actually want transitioned to Glacier. And so I'm very excited to share that a couple weeks ago, S3 launched a really powerful new feature that enables far more granularity when it comes to designing lifecycle policies. We announced that you can now add up to 10 tags to any of your S3 objects, and that lifecycle policies can refer to these tags. And so in the example that you see here, the policy still applies to the entire bucket, but now the rule only executes for objects with the tags project equals delta and data type equals HPI. So as you can imagine, the variations here are limitless and really enables you to be specific about which objects you want to be lifecycled into Glacier. In addition, many customers have asked for the ability to manually transition data to Glacier one object at a time, regardless of the age. And object tagging enables that. And the way that works is you would create a zero-day lifecycle policy on a bucket that applies to a certain object tag, such as whatever it might be, say Glacier storage class. And then meaning that any object with the tag Glacier storage class will be transitioned to Glacier immediately. Therefore, to transition a single object manually via an API call, you simply make the API call to add that tag to that object. So these are two things that customers have asked for a long time, and really makes the lifecycle feature a very, very powerful tool for you to use to manage all of your object storage under each of the classes, storage classes that AWS offers. Another management feature that customers like to use is tagging for vaults within Glacier. You can tag vaults with a key value pair such as department equals marketing. And then you can use those tags to view Glacier costs by tag in the AWS billing dashboard, for example. Or you can leverage those tags to more easily create specific access policies that meet your security requirements, such as give this user access to any vaults, where department equals marketing, for example. So, data archival often involves business critical data, and many customers require audit logging to know who did what, when, whether that action was approved or denied, and why. And so Glacier customers have access to such logs via AWS CloudTrail, which can be enabled very easily with just a few clicks in the console. These logs apply to all Glacier APIs, both on the control plane events at the vault level, as well as data plane events at the archive level APIs. So this is a powerful tool that's available for you to be able to do audit logging and have that security control. Glacier also offers 2 access control features that makes it really easy to manage access to your Glacier data. One is vault access policies. So rather than having to define the vaults that each user has access to, with vault access policies, you can create access policies on the vault itself that governs access to the data in that vault. For example, you can create a policy on a vault that prevents any user from deleting an archive within that vault. You can also enable MFA rules, multi-factor authentication rules, such as requiring MFA authentication to delete any archive in that vault. One of the more important use cases that vault access policies enables is the ability to grant access to cross accounts. Many customers, particularly for example, in the media space, use Glacier to store content that is actively accessed for things like broadcasting and other workflows, which often involve partners or other departments with separate accounts. So vault access policies makes this easy to control and enable. Vault access policies are very easy to set up. You can set up vault access policies using Glacier's APIs, the AWS SDK, the AWS CLI, or by using the Glacier console. For those who require really strong governance on access, and in particular on data retention, Vault Lock enables you to create an immutable access policy on a vault. Many regulated industries require this, particularly in the financial services sector. For example, some regulations require certain data sets to be non-overridable and non-erasable by anybody, including the root user. So Vault Lock enables this, and Vault Lock also enables time-based rules based on the age of the archive. Using Vault Lock is a very simple 2-step locking process. First, you initiate, send an initiate Vault Lock call, which you would include the policy and then allows you 24 hours to test that policy before it's locked and becomes immutable. And after 24 hours, it will automatically expire, or you can also delete that policy if it's not exactly what you wanted. So initially, there's this 24-hour testing period to make sure it's absolutely what you want. You have the option to abort it if you want to and modify it before locking it down. And then finally, once you're completely sure that the policy is exactly what you want, you complete the Vault Lock by sending a complete Vault Lock API call. This locks down the vault with the appropriate lock ID, and that Vault Lock policy can no longer be aborted at that point, is immutable even by the root user. So here's a great example where we combine, of leveraging Vault Lock, where we combine vault level tagging, cross-account access via vault access policies, and Vault Lock to enable a legal hold feature on a vault. So in this case, you would set up a legal hold tag on the vault, and initially you would set the value to false, and then you would add the compliance control for legal hold and define the policy, In this case, you would want to define it as denying delete, the delete archive operation from anybody, including the root administrators, users, etc. And then with the condition that where legal hold equals true, then you can then place or lift legal hold simply by updating the tag value on that vault. And here's just a quick look at what that would look like, just a few lines of code, and yet a very powerful policy and very powerful feature. A couple of tips and best practices when using Vault Lock. One, it's a good idea to map one vault to a single retention range. We enable one policy per vault, and so grouping regulatory data by their retention age is a good idea. Create a new vault and lock it before storing production data. This prevents gaps on any existing archives that might exist in the vault that are related as it relates to the policy that you've defined. You also want to be sure to thoroughly test a vault lock policy before locking it down, since it's immutable even by the root user. And then finally, implement only the most restrictive controls using vault lock, and consider using vault access policies for use cases where you want more flexible controls. And then finally, Vault Lock has been assessed by Cohasset Associates, which is a highly respected consulting firm with more than 40 years of experience and knowledge related to the legal, technical, and operational issues associated with the records management practices of companies that are regulated by the SEC and the U.S. Commodity Futures Trading Commission in particular. And the full assessment is available online, and it provides a detailed look at how Vault Lock can be used to meet regulatory requirements, in particular for the SEC 17A-4F and the CFTC 1.31B-C. Moving on to data retrievals. So data retrievals is it's kind of 4 events that happen, and it's a 2-step process for the users. First, you initiate a job requesting, and this is at an archive level, so you request a particular archive from a vault. Then there's the retrieval processing that happens, which can take anywhere between minutes or hours depending on the retrieval option that you choose. When the job completes, then you're notified that the job is complete and is available to be used or to be downloaded. And so the emphasis here is that accessing your data from Glacier involves 2 steps. First, you initiate a retrieval, and then once it's completed, you're able to then download it and access that data. And to give you a quick example of how that looks in S3, if you're using Glacier via Lifecycle policies, you can restore data from the Glacier storage class using the console. And so here's a quick look at what that looks like. You can select an object within your bucket. You select Initiate Restore, at which point you'll be prompted to specify the number of days in which you want this restore to occur. Now keep in mind that this is not a move, but rather a temporary copy of your data. So the data is still stored within Glacier. That object is still stored within Glacier, but a temporary copy is made available as if it were stored in S3. And is then, once the retrieval process is completed, then it is available for the number of days that you specify at the typical S3 performance and availability levels. And when you first initiate the restore request, the status will show that the restoration is in progress, and once it's completed, it'll update, the status will update, and you'll see how long that object is restored and accessible for. Fairly simple process. One feature that we offer as it relates to data retrieval is data retrieval policies. This allows you to manage your retrieval costs, and you can choose between three options. One is to limit your retrievals to the free tier only, which is 10 gigabytes per month and can be used at any time. The other is to set a max retrieval rate, which is controlled at the gigabyte per hour level. And then finally, you can also set the policy to have no limit and allow you to retrieve any data, any amount of data at any time. And finally, I'd like to close this session, finalize this presentation by introducing Glacier's new retrieval options and new pricing model. The overarching goal of these launches was to provide customers with a powerful set of retrieval capabilities that enables you to access all the data that you need when you need it with a low, predictable price. Previously, Glacier enabled you to access your data in 3 to 5 hours, which we are now calling standard retrievals. This option will continue to be available and is a great low-cost option for retrieving archives in just a few hours. The previous pricing model for standard retrievals used to be based on the peak rate of retrieval and applied to all hours of the month, similar to a bandwidth charge. And we heard from customers that this was complex and difficult, made it difficult to predict costs. And therefore, as of November 21st, we have completely replaced the rate-based pricing structure with a simple, flat, per GB price of 1 cent per gigabyte, regardless of how fast or how much data you retrieve. Additionally, customers have long asked for two things that would enable a number of different use cases that are really important to archival workloads. First was the ability to access data in minutes. And so we launched expedited retrievals, which allows you to access data in 1 to 5 minutes. Expedited retrievals are designed to address that occasional need to access a small number of archives urgently. And this is partly reflected in the pricing, where retrievals cost 3 cents per gigabyte and 1 cent per archive retrieved. This capability is really empowering use cases, exciting use cases like media broadcasting, where for example, in that case, the majority of the time, the broadcast schedule is known well in advance and is well served by standard retrievals, but where occasionally there's that last minute change that needs to be accommodated within a few minutes. The other thing that customers asked for, especially for use cases such as mass content distribution, bulk transcoding, big data analytics, and many others, was the ability to retrieve large amounts of data for a very low cost. And so we launched bulk retrievals, which cost just 1/4 cent per gigabyte and 2.5 cents for 1,000 archives requested. When you use bulk retrievals, data is retrieved within 5 to 12 hours, and bulk retrievals really enables you to cost-effectively retrieve large portions of your data, even petabytes, for a very low cost. So using the new retrieval options is very simple. There's a new parameter in the existing Retrieval API where you simply specify which retrieval option you'd like to use. And if you don't specify the option, the retrieval request will default to the standard retrieval option. And so, any existing applications or requests will still work as previously, although with the new retrieval pricing. And it's also important to point out that these new retrieval features, expedited and bulk, are also available to customers who use Glacier via S3 Lifecycle policies. A couple things to note about expedited retrievals. There are two types of requests: on-demand and provisioned requests. On-demand requests, like EC2 on-demand instances, are available the vast majority of the time. And if you require a guarantee that expedited retrieval capacity will be available when you need it, you can use provisioned requests by purchasing provisioned capacity. Provision capacity units cost $100 a month, and each ensure that at least 3 expedited requests every 5 minutes are delivered and provides up to 150 megabytes per second of retrieval throughput. Apart from purchasing the provision capacity units, there's no additional steps necessary to make provisioned requests. Once you own provision capacity, all your expedited retrieval requests will be treated as provisioned requests. So really, with the new retrieval options and the flat per GB pricing, Glacier is now more than ever a powerful storage solution that addresses the full spectrum of your archival use cases, ranging from deep archives that are never retrieved, that can really take advantage of Glacier's ultra-low storage price, to active workloads with minute-level access, such as media broadcasting, all the way to petabyte-scale content distribution or big data analytics use cases, and many others where not only are customers cost-effectively storing petabytes of data, but are also accessing and extracting value from petabytes of data at a very, very low cost. And so with that, I'd like to thank you for joining me and listening to this webinar, and move on to Q&A.
For that presentation on Amazon Glacier. And thank you all for taking the time to listen in today and for submitting a lot of great questions. I believe we've addressed quite a few via the Q&A pod, but we apologize in advance if we might not have been able to answer everyone's questions. We do have a log of all questions from today's webinar, and the team will work hard to respond to you all in a timely manner. If you didn't see a response today during the presentation or a response in the next few days via email, please post your questions on the Amazon Glacier form so we can get an answer to you. And with that, we do have some time left for our webinar, so we'd like to give Moz some time to respond live to some of the questions that have been submitted. A quick reminder before I pass the mic back to Moz to you all to please respond to the 3 polling questions displayed on the left-hand side of your screen so that we can continue to improve our webinar experience for audiences like yourself. And with that, I'll just pass the mic back to Moz to respond live to some of your questions that we received today.
Thank you, Nicole. So one question is retrieval pricing based on per archive, regardless of the archive size? So it's both. There's both a per request cost as well as a per GB cost. So for taking standard retrievals as an example, if you retrieve a 1 gigabyte archive, then there's a 1 cent per gigabyte charge, and then there's a 5 cent per 1,000 archive request charge as well. So whatever 5 cents divided by 1,000 is. Another question is, how often can one exercise expedited retrievals, and is there a limit? There is no limit, but there are, as I said, there's 2 types of requests. There's on-demand and provisioned requests. If you need a guarantee that expedited capacity will be available when you need it, then you might consider purchasing some provisioned capacity units in order to ensure that. But it's similar to EC2 on-demand instances where really the vast majority of the time expedited requests are available. And again, I'd also note that it's really designed for that occasional urgent need for a small number of archives. One question also is, how do you delete a vault when a vault lock policy is set and when it's finally okay to delete it? And once regulatory data exits the retention period based on the policy that you've set, for example, 7 years for financial services, then you can delete the archives and delete the vault. You will need to delete all the data in the vault before you can delete the vault, and that applies, whether you're using vault lock or not. Another question is, what would be the difference in S3 infrequent access and Glacier accessing in minutes? And I think this is really two questions. One is do you need millisecond access to your data? If so, you should use either S3 standard or S3 standard infrequent access. If you're okay with, if you don't require millisecond access, then when comparing S3 infrequent access and Glacier using expedited retrievals, it really becomes about how frequently you're retrieving data and the amount of data that you're retrieving when you do, and it really becomes an economic question. The retrieval pricing is different. With S3 infrequent access, retrieval costs are 1 cent per gigabyte. And with expedited retrievals using Glacier, it's 3 cents per gigabyte and 1 cent per archive requested. So I would suggest taking a good look at what your access patterns are for your data set and doing an evaluation of both the performance as well as, but mainly the economic aspects of your use case, and then making a decision based on that. Looking through these questions here. Do we need to always get object from Glacier to S3, or can we get it directly from Glacier? This is a good question. So when moving from when uploading your data into Glacier, if you decide to use Glacier via Glacier's APIs directly versus via lifecycle policies, once you've made that decision, then your experience and you're working on your ability to access that data is through that door once you've chosen that. So if you're using Glacier storage class via S3 Lifecycle services, S3 Lifecycle, then you'll access your Glacier data using S3 APIs and vice versa with Glacier APIs directly. Another question was around the free tier. So previously with rate-based pricing, we had a 5% free tier, which was really designed to accommodate most retrieval use cases and avoid the rate-based charges altogether. And so with the introduction of these new flat, very low-cost retrieval options, we're simplifying the free tier to be 10 gigabytes per month, and that applies to the standard retrievals, and those can be used at any time. In other words, they're not prorated daily as it was before. The retrieval options are really designed to enable you to retrieve and accommodate any use cases. And I think that if you model out your access patterns, and if it's a real archive use case, you'll find that your total retrieval costs will be a very small portion of your total Glacier costs. While also, so really they've been designed to both lower your retrieval costs as well as really increase the flexibility in your ability to access your data. In particular, in combination with the recent storage price drop for Glacier from 0.7 cents to 0.4 cents per gigabyte per month. So another question is, for backups into S3, say for Redshift or EBS volumes, how can we move them into Glacier based on automated rules? So if you're using EBS snapshots, currently today we do not enable the ability to transition EBS snapshots into Glacier. It is a feature that is certainly that we're aware of and has been a common customer request. If your data is, if you yourself are backing up data into S3, then certainly any S3 object in your buckets can be transitioned into Glacier, including Redshift or EBS volumes that you yourself are backing up into S3. But know that we have that customer request on our roadmap, and is something that we are tracking actively. Another question is there a minimum size of object to be stored in Glacier? And there's no minimum size, but again, keep in mind that there's an overhead charge of 32 kilobytes per object per archive. And so you really want to be targeting, kind of a multi-megabyte object average archive size when using Glacier in order to minimize that overhead cost. But you can store any size object in Glacier. Another question is, does the durability of Glacier have any dependence on the frequency of retrieval? And the answer to that is no. The durability of Glacier is, 11 nines of durability regardless, and there is no relation between the durability and your frequency of retrieval. We store all of your data durably, and the performance and the ability to access your data is the same regardless. And that covers all the questions for today, and I'll hand it back to the moderator.
Thanks, Moz. And that concludes our webinar on a deep dive on Amazon Glacier with new retrieval features. Thank you all for taking your time out of your day to learn more about AWS services. I'd like to extend a special thank you to our presenter, Moz Kubo, for his time and for sharing today's content with you all. If you have any comments on our previous and upcoming webinars or suggestions on the topics you wish AWS may cover in future webinars, please feel free to email aws-webcast@amazon.com. As always, your feedback helps improve our webinar programming. Thank you.